Hello students, a very good morning to all of you. Now see, we will continue our topic of real number. Previously we have learnt about the fundamental theorem of arithmetic. After that you might have tried some question. Today we will learn some properties that will be helpful for us while solving problem. Now see students, you have idea about terminating and recurring decimals. I am repeating again and again because you have to solve problems related to it. You will get some questions from this topic. So we know that if decimal expansion of rational number p by q terminates means what? That it comes to an end. Then the decimal obtained from p by q is called terminating decimal. It means that after dividing the result comes to an end. That type is known as terminating, and the just opposite of it, if it does not come to an end, or we can say that the decimal expansion obtained from p by q repeats periodically, then it is called non-terminating or repeating recurring decimal. Is that clear? Now see, let x is equals to p by q be a rational number such that the prime factorization, you know how to do the prime factorization. If you find the prime factorization is of the form 2 to the power n, 5 to the power m. It means what? Suppose 2 to the power 2 and 5 to the power 3, like that, where n and m are non-negative integers. Then x has decimal expansion which terminates after k places of decimals, where k is the largest of m and n. So if you find the pattern is of 2 to the power n into 5 to the power m. Another property is let x be a rational number whose decimal expansion terminates. Here already it is given that its decimal expansion terminates. Then x can be expressed in the form p by q. Is that clear? If its decimal expansion terminates, then only it can be expressed in the form of p by q, where p and q are co-prime, and the prime factorization of q is not of the form 2 to the power n into 5 to the power m, where n and m are non-negative integers. You should be very careful about this property because this property will help us. Now see again, if x is equals to p by q be a rational number such that the prime factorization of q is not of the form 2 to the power n into 5 to the power m, where m and n are non-negative integers, then x has decimal expansion which is non-terminating repeating. What I said? Then if you will get 2 to the power n into 5 to the power m is not in that form, then that decimal expansion is non-terminating repeating. See, you have to check without division. Suppose here, check whether it is terminating or non-terminating repeating decimal expansion. For this, what you have to do? Just one example I have given, 13 by 3125. Now see, here the last part is 5. So after doing prime factorization, we will get of this form 5 to the power 1, 2, 3, 4, 5, 5 to the power 5. So we have written like this. So we are getting what? 5 to the power m form. So here we can say that it is must what? Terminating decimal representation. See students, you will get 1 mark questions out of that. Now see, you have to solve certain problems related to it, as I have given some questions for practice. You have to show that 3 root 2 is irrational. You can take the help of the previous questions which I had solved, and you solve this question. After that, you have to prove root 5 is irrational. Then again you have to prove 6 plus root 2 is irrational. And after that, students, please you try to solve NCERT exercise 1.4 of page number 17. See, of question number 3, prove that 6 plus root 2 is irrational. That type of questions I have solved here for you as an example. Here we have to solve that 3 plus root 5 is an irrational number. For this, what I have done, let 3 plus root 5 is a rational number. This we assume. Now, if it is a rational number, we can write it in the form of p by q, where q not equals to 0. Again, we have to write root 5 is equals to p by q minus 3. So, if we have solved 5 minus 3 by root 5 is equals to p minus 3q by q. So, root 5 is irrational and this is irrational. See, root 5 is irrational and P minus 3Q by Q is rational, but this contradicts because a rational number cannot be equal to irrational number. Hence, we can say that 3 plus root 5 is an irrational number. Hope you understand this. If you face any problem, please you contact anytime or in between 2 to 4 p.m. Till then, for now, bye.